Hey, we're back. All right. So you should have basically already done your homework in integration by parts, just regular and tabular. Okay. So if you have any questions about those, just let me know. So now we're going to start section 8.3 in your books on your favorite thing, trig. So we're going to do trigonometric intervals. Okay. So this video is going to deal with sine, cosine, and then the next video later will deal with like secant and tangents. Okay. So if you're doing an integration and it's not one you have memorized, like remember if it's just one sine, you just need the derivative of the angle. And if it's integration of cosine, you need the derivative of the angle. But this one you have powers greater than 1 with sine and cosine. So let me go pull up a PowerPoint and we'll talk our way through it, hopefully. Okay. So let's kind of see where we are. All right, so let's go up to the beginning. So we're going to talk about section 8.3 on sine, cosine, trig intervals with your powers greater than 1. Now it's going to start, basically there's a difference between the way you work them when you have an odd power on your sine or cosine and when you have only even powers. So let's kind of start with the odd powers possibility. So if you have an odd power of sine or an odd power of cosine or odd powers of both, then basically what you're going to do is save one that you have an odd power. So look what it says. If the power of sine is odd, now it says and positive, but I think all the ones in your book are positive. But if the power of sine is odd, you're going to save one sine, and then everything else has to turn into cosines. Okay? If the power of your cosine is the one that's odd, then you save the cosine. And if you save a cosine, then everything else turns into sines. Now, what you're basically doing is this. Remember that the derivative of sine is cosine. And the derivative of cosine is sine, negative sine, but you just have to change the SIGN. So what you're really doing is you're going to save one thing, and that one thing that you're changing ends up being the derivative for a power rule. All right. So if both powers are odd, then you just get, is your personal preference. You can save whichever one you want. So notice what it says. You're saving the derivative and you're changing the rest of the integral so that you can use the power rule. So let's go look at one so I can kind of show you what I mean by that. All right, we're integrating sine squared x times cosine cubed x. So notice you have an odd power. Okay, so since cosine's the one with the odd power, we're going to save one of the cosines. So if we save one of the cosines, that's going to leave me two of them. So I didn't touch the sine squared. So remember, cosine squared plus times cosine is where I got the cosine cubed. Now remember what I said, this thing that you're saving is the derivative of something. Now what is cosine the derivative of? That's right, sine. So if you save a cosine, everything else has to be sines. Well, sine squared is already sine, so it stays the same, but now I've got to change cosine squared to something to do with sine. Now remember that Pythagorean identity that you're supposed to have memorized, that sine squared of an angle plus cosine squared of an angle is 1. So if you solve that for cosine squared, you know, if you subtracted sine squared from both sides, cosine squared would be 1 minus sine squared. So that's how I turn cosines into sines. Now, the reason I have this thing that I saved in red and underlined, because on my paper, if you were to watch me working on my own paper, I always underline it. That reminds me, this is going to end up being the derivative of something, so don't mess with it. So notice it just kind of comes down throughout the problem. So I take my sines and I multiply them out. Sine squared times 1 is sine squared, and then sine squared times sine squared is sine to the 4th. Now notice this cosine x is times both of these. So I break the integration up into two integrands, and I distribute that cosine. So that's why I get sine squared times cosine and sine to the 4th times cosine. Now we're going to end up doing power rule, so it may make a little more sense to actually rewrite this so that you can see that it's power rule. Because remember, what you're really squaring here is the whole sine of x. So there should be an x right there. Okay? So sometimes, you know, when I'm making the videos, I'll make a careless error and I'll have to fix it, like right here. So that should be sine x on the inside. Then I've got sine x to the 4th power over here. Now, remember when you have power rule, you have to have the derivative of the inside next to it. So what's the derivative of sine of an angle? It's cosine of that same angle, and then times the derivative of your angle is 1. Okay? And the same thing here. The derivative of the inside, the derivative of sine x is cosine x, and then the derivative of that x is 1. So I've got two power rules. So remember what power rules do. The inside stays the same and your power goes up. So that 2 would go up to a 3 and you divide by 3. Remember that power rule, that 4 would go up to a 5 and you would divide by 5. Now, if you'd rather write sine x in a parenthesis to the 5th power instead of sine to the 5th, then you're welcome to do that. It's just the book a lot of times will kind of write the answer that way. Okay, so let's kind of go look at another one just to kind of make sure that we understand what I'm saying. All right, now the odd power is the one that you saved. Now sometimes you don't recognize things. Now this isn't one that you have memorized and you don't see a power, but think about it. When there's not a power, showing that's a power of 1, so it's odd. So that's why I saved my sine 2x. Now the lucky thing is, remember, if you save a sine, everything else turns into cosines. Well, everything else is already cosine. So that's what I mean by sometimes it's already set up, it's already ready, it's an easier one. So don't make it harder than it is. Now, my problem though, so I've got the cosine of this times that. Now think about it. So that's really cosine 2x to the 4th power. So I need the derivative of the inside. Well, what's the derivative of cosine of an angle? Well, it's negative sine of that same angle. So I had to take that sine and multiply by negative here, so I had to multiply out there by negative. And then remember, you always need the derivative of your angle. And the derivative of 2x is 2, so that's why here I have a 1/2. So this negative sine 2x and 2 is just the derivative of the inside for your power rule. So remember, with power rule, you have your original cosine 2x, and your power goes up by 1. So it goes up to 5, and then I divide by that same power. So that's why I got this answer down here. Now, if you'd rather leave it like this step instead of going to this step, that's fine for me. It's just this is what they normally will have written in the back of the book. But I'm good either way. Okay? Now, sometimes you kind of have a choice. And here's what I mean by you kind of have a choice. On this one, notice both of them are odd powers. Okay? So my cosine is an odd power of 3. My sine's an odd power of 5. So I have the choice of whether to save a sine or a cosine. Now, if you have a choice, you really want to save one of the smaller power. Okay, and you'll see why. I'm going to work it both ways so that you can see. When you save the smaller power, though, it's less work. All right, here's what I mean. Since 3 is smaller than 5, and both of them are odd, I'm going to save a cosine. Now, there were 3 of them, so if I save 1, that would leave me 2. Okay? Now, remember, if you save a cosine, everything else has to turn into sines. So that sine to the 5th just stays sine to the 5th, and then cosine squared would be 1 minus sine squared. Now remember, I'm going to save this, and I'm not going to touch it anymore. That's going to end up being the derivative of the inside for power rules later. So save the thing that you're saving, and then multiply everything else out. So 1 times sine to the 5th is sine to the 5th. A sine squared times a sine to the 5th is a sine to the 7th. Now notice this cosine goes with both of these. So I'm going to separate the integrals. So I've got this one times my cosine, and then minus, I have that one times my cosine. So I just split it up into 2 integrations. So remember, I've got power rules. So I need the derivative of the inside. So what's the derivative of sine of an angle? Well, it's cosine of that angle, okay? So cosine of that 4x. Then I need the derivative of the angle. So I need the derivative of the 4, all right? So I need that 1/4 out here. If you multiply by 4 here, you got to multiply by 1/4 out there. All right, same thing here. I've got something to a power, so I need the derivative of the inside. So the derivative of sine of an angle is cosine of that same angle, and then times the derivative of the angle. So you multiply by 4 here, you have to have a 1/4 out there. So this is just power rule. So my 1/4 comes down. I have my original. Remember, my power goes up by 1 to 6, and I divide by that same power. Same thing. That power is going to go up by 1, so it goes up to an 8, and I divide by 8. Then all I did was multiply the denominators out. okay? So that's what I'm going to do when I have an odd power. But remember, they were both odd, so I could have saved a sine instead of saving a cosine. But look how much more work that would be. If I saved a sine, all right, so I have 5 of them, that would leave me 4. But the only substitution that I know is for sine squared, not sine to the 4th. So I'd have to look at that sine to the 4th as a sine squared times another sine squared. So then I've got to do a substitution from this one, and then I've got to do a substitution from that one. Well, see, both of those sine squareds would be 1 minus cosine squared, okay? Let's make sure that 4x is there, okay? So when I save a sine, remember, everything else has to turn into cosines. So everything else turned into cosines. Now I just multiply all 3 of those together and get this thing. Now, if you want to, you can pause the video and do the multiplication and double check it, because I'm bad to make a careless error, just like I do in class. So if I make a careless error, then you need to fix that. Okay, you can email me and I'll go back and kind of fix the PowerPoint. Okay, so you multiply all that up and you get this. Now remember, that's 3 different terms all multiplied by sine 4x. So I'm going to separate it into 3 different integrals. So I've got this cosine cubed times the sine x. I've got that 2 cosine to the 5th times that sine x, and I've got the cosine of the 7th times that sine of 4x. So it's going to be 3 different power rules. All right, now remember, if you want to write that power outside so that you can see it better and notice it's a power rule, that's usually helpful. So when you have something to a power, remember you need the derivative of the inside. Okay, so what's the derivative of cosine of an angle? Well, it's negative sine of that same angle, so there's a negative out here in front of that 1/4 that you can't really see very well. Then you need the derivative of the angle. So the derivative of 4x is 4, so multiply by 4, you got to multiply by 1/4. So I've got a negative 1/4 in front. All right, I took that 2 and just pulled it out, so that's where that 2 is coming from. So now I've got this cosine 4x to the 5th power. So power rule, when you got something to a power, you need the derivative of the inside next to it. So what's the derivative of cosine of an angle is negative sine of that same angle. So multiply by negative here, you've got to multiply by a negative right there. Then I need the derivative of the angle, which is 4. Multiply by 4, you got to multiply by 1/4. So that's where that negative 1/4 came from. Same thing here. Got something to a power, so this is the derivative of the inside. It got cut off, but there's a 4 out here as well. So I multiplied by this negative and this 4, so there's a negative 1/4 in here. All right, so I've got a negative 1/4, and it's just power rule. So my power went up to a 4, and I divided by a 4. Now, minus a negative is a plus, and then 2 times a 4th is an 1/8. So that's where that came from. And then this is power rule. So I keep my original cosine of 4x, and my power goes up by 1, so it goes up to a power of 6, and I divide by the same power. And then similarly out here, I've got this plus and negative is the same thing as a minus, and there's that 1/4 that was in the front. Power rule, so my power went up by 1 to an 8, and I divided by that 8. And then just multiply the bottom out and get a 16 on the bottom. And then I'm going to have a 48 on the bottom here. Then I'm going to have a 32 on the bottom there. Okay? All right, so there it wouldn't matter which one I did, but the first one was simpler, okay? It was less likely to make a careless error. The longer it is, it's not harder, it's just more tedious, and you're more likely to make a careless error. But either answer would have been right, but in the back of the book, they're only going to have one right answer. So sometimes your answer might be correct and just be a different form than the back of the book has. So, review for a second. So if you've got an odd power of sine, save a sine. If you've got an odd power of cosine, save a cosine. If you have odd powers of both, you can save either, but I would save one of the smaller power. Then remember, if you save a sine, everything else turns into cosines. If you save a cosine, everything else turns into sines. Now, let's look at what would happen, though, if you only had even powers. If you only had even powers, let's try to go back. If you only had even powers, then what you're going to have to do there is you're going to have to use a different substitution. Okay? So let's try to get some of this blue erased so we don't have to get confused by that. So if you only have even powers, there's some substitutions in your book on page 532. All right. So those substitutions, I'm fixing the corrections from the last one. So on those substitutions, cosine squared is 1 plus cosine of twice that angle over 2. Sine squared is 1 minus the cosine of twice that angle over 2. So these substitutions look almost the same, except one's a plus on the top and one's a minus. So when it's cosine, it stays a plus. When it's sine, the sign switches to minus. Okay? Now, let's go back for a second. I keep flipping on this. Now, what I want to make sure you understand doesn't literally mean 2x. It just means double the angle. If this is x, that's going to be 2x. So if this were a 2x, that would be a 4x. If it was cosine squared 5x, that would be 1 plus the cosine of 10x over 2. So whatever this angle is right here, you double it right there. Okay, so let's go look at one to see what I'm talking about. See, I don't have just one. If it was just one sine, that'd be one I had memorized. It's not an odd power, so I can't save one. It's an even power. So when it's even, you've got to do one of those substitutions. And sine squared is 1 minus the cosine of 2x over 2. Okay? Because if your angle's x, when you double x, you get 2x. All right, I don't need the 2 in the bottom, so I pull that out. It's really a 1/2 because that 2 is in the bottom, and it leaves me that 1 minus cosine 2x. So I've got two different things, so I just split them up into two different integrands. So 1 times the dx, and then the cosine 2x times the dx. But notice that 1/2 goes with both. So 1/2 times the first integration, and then minus, and then that 1/2 times that second integration gives me that. Well, now this is one I can already work. When you integrate dx, you just get x back. So that's where that 1/2 x came from. Now, this isn't power rule. This is one you had memorized at the very beginning. You know, when you integrate cosine of an angle, all you need is the derivative of the angle. So you're missing the derivative of the angle, which is 2. So if you multiply by 2, you got to multiply by 1/2. So, of course, 1/2 times 1/2 is 1/4. And then, of course, you're supposed to have memorized when you integrate cosine, you just get back sine. Okay? So don't get the power rule confused with the very first one that you worked. Now, sometimes it doesn't get harder, but it does get longer. All right, here's what I mean. See, I don't have an odd power, so I can't save. All right. Now, this also happens when you have a mixture of sines and cosines. If you only have even powers, then you have to use those substitutions on page 532. So cosine squared is 1 plus cosine of twice the angle over 2. Now, why does it say 6x? Because my angle is 3x, so when I double that, I get 6x. Okay, and the same thing here. When I double my angle of 3x, I get 6x. So that's my substitution. I don't need the 2 on the bottom here or here. So 2 times 2 is 4, but it's on the bottom, so I pull that 1/4 out. So that leaves me the 1 plus cosine 6x times the next 1 plus cosine 6x. Now I multiplied that out. You know, 1 times 1 is 1. I get cosine of 6x plus another cosine of 6x gives me 2 of those, and then cosine times cosine is cosine squared. So I end up with 3 different terms, so I'm going to split it into 3 different integrations. But also notice that 1/4 is times the whole thing, so that 1/4 goes with all 3. So 1/4 times this 1 dx, then 1/4 times this 2 cosine 6x, and then this 1/4 times this cosine squared. Now this one, basically I can already do. I'm going to wait and do it later, but I already know how to work that one. I don't need the 2, so I pull it out, and it leaves me cosine of 6x. Now here's a problem. I can't do that one, and it's an even power again, so I'm going to have to do it again. Remember what cosine squared is. It's 1 plus the cosine of double that angle. So when you double 6x, you get 12x over 2. Okay? Now I don't need that 2, so when I pull it out, that 1/2 out, that's where I get 1/8 right there. So this one, I just kept the same because I can already work it. Well, of course, 2 times 1/4 is 1/2. Remember what you have when you have cosine of an angle, you need the derivative of the angle. So your angle is 6x, so the derivative of 6x is 6. But if you multiply by 6 here, you got to multiply by 1/6 out there. All right, same thing. Then we pull that 1/2 out, so it left me 2 integrands that I'm going to break up down here. Okay, so basically that just came down. Of course, 1/2 times a 6 is a 12th. Now I have that 1/2 times the first one, and then I have, excuse that 1/8 times the first one, and then that 1/8 times the second one. Okay. So again, everything's the same here until I get to here. I've got cosine of an angle. My angle's 12x, so I need the derivative of that, which is 12. But if you multiply by 12 here, you got to multiply by 1/12 out here. So now I've got all 4 integrands set up, and I know what to do. So the 1/4 comes down. When you integrate dx, of course, you just get x. The 1/12 comes down. When you integrate cosine of an angle, and you have the derivative of the angle, of course, you just get sine of that angle. Now, 1/8 times the integration of dx, again, is just x. And then 1/8 times 1/12 is 1/96. And again, when you integrate cosine of an angle, and you have the derivative of the angle, you just get back sine of that same angle. Now, you could, which I did, I can combine this 1/8 x and that 1/4 x. So you know 1/4 is 2/8, so 2/8 plus 1 more 8 is 3/8 x. And then I've got my 1/12 the sine of 6x, and my 1/96 the sine of 12x. And then because it's indefinite, don't forget that plus c. Okay, so it matters whether you have an odd power of sine and cosine or an even power of sine and cosine. Remember, with an odd power, save one of your odd powers. And if you save a sine, everything else turns into cosines. If you save a cosine, everything else turns into sines. And then you're going to do power rules. But if you only have even powers, you do those double angle substitutions, okay? And those don't end up being power rules. You just end up needing the derivative of your angle on all those. Okay, I've got some homework posted, so, you know, go watch the video again if you need to kind of double check. You can always freeze it, try some things on your own, and then go try that homework. Now, if you're having trouble with the homework, you need to contact me, okay? Now, you got a couple of ways of doing that. You can come to a Zoom meeting, okay? Remember, we have Zoom meetings at 9 o'clock every Tuesday. You can ask me to work problems, and I'll be happy to work them. You can email me and snap a picture of your work and attach that, and I'll try to find your mistake and send you some feedback. I can do a one-on-one Zoom meeting. Just send me an email and go, Dr. Dan, I kind of need some one-on-one tutoring. And we'll figure out a time to kind of meet on Zoom and do that. So you've got plenty of opportunities to get help if you need it. Okay, but stay caught up. Don't get behind. Watch the videos and do the homework. And I'm going to post them a week at a time so that you can kind of do them, you know, kind of at your own rate, but make sure that you get them done, you know, in that time frame. And let me know if you need some help. Okay, you know I love tricks. Okay, so let me hear from you. Y'all have a great day.